A lot of times when you're learning about stuff in school, especially in science class, you get a big long list of facts from your teacher and you copy it down, and you don't really know where all those ideas that the scientists came up with really came from. What work did they do to come up with that idea? And so that's the whole point of us learning about light first, so that we understand why scientists came up with the ideas that they did, and what did they do to study the universe if we can't visit most of the places in the universe. So in this next part of the online lecture, I'm going to show you some pictures of some spacecrafts that have taken some pictures using different kinds of light to tell us things about objects in space. And then also I'm going to show you the pictures that they took so that we can see what it's like out there. It's kind of like right now you can see the construction. It's kind of like eating at a restaurant but not knowing how to cook. Like, you can still appreciate the meal, but it's so much better when you know what's going on in the kitchen. This goes back to what I was saying in the intro, that sometimes we are so caught up in what scientists have found out that we don't think about how they saw it or how they found it out. And so what we're going to talk about is how they see what they see from space, along with some of the cool things that they have seen. So in radio astronomy, with radio and microwaves, they kind of get lumped in together. You can see things like these jets coming out of a supermassive black hole at the center of a galaxy. And really wouldn't be able to see that without using radio astronomy. And they do that using these telescopes that are called very large arrays. So these are individual telescopes that are in an array put together that make a larger telescope. And why do you think radio astronomers use so many telescopes? Hit pause, and I'll tell you the answer in a sec. So the answer is all the telescopes together function as one giant telescope and create like a larger bucket to catch all those radio waves or radio EMR radio light. And this can work because radio waves are so long. They're just so big that they need a giant telescope, and it's hard to build just one single giant telescope, so they use a lot of smaller ones and put them together to make a larger one. Infrared. Infrared, like I said earlier, makes its way a little bit further into the atmosphere than some of the other ones that get blocked by the atmosphere, and so they can put it in a plane. So this is a telescope called Sophia that is mounted to a plane, and so if they fly the plane, which is cheaper than putting something in space, they can still get infrared images from space. And so if you remember from the lab, here goes some everyday infrared. So question 8. This is Jupiter's moon Io. What is causing these bright patches in infrared on this moon? These are brought to you by Galileo, the space telescope, not by the person. He's been dead for a while. So yeah, pause. Volcanoes. These are hot spots, or hotter spots than the rest of the surface of the moon of Io. And those are most likely caused by volcanoes. This is the space telescope called SOHO, solar something something something. This is a cool telescope because instead of looking at through just one type of light, this has lots of different types of light, but it only looks at one thing. It only looks at the sun, and it is constantly staring at the sun, looking at it through different types of light. And so this is the sun through SOHO, looking at visible light, and you can see some sunspots on there. Um, More visible light is brought to us by the Space Telescope Hubble, like I talked about earlier. So you have this galaxy, and this picture is really cool. The story behind it. I was talking to scientists at the Museum of Nature and Science, and what he said that scientists did is they pointed Hubble at the darkest spot in space, the part in space where it looks completely black and looks like there's nothing out there, and they just kind of held the camera there for a long time, or held the telescope there with the camera on it for a long time, and a really long exposure, and they brought those pictures back, and this is what it looks like. So even the darkest spots in space still have thousands and thousands and millions of galaxies in them, and each one of these galaxies has billions of stars. So billions of galaxies and billions of stars out there in the universe. This is SOHO again, and this is the sun in UV. So this is the UV light coming off of the sun. Once again, SOHO's looking at it, translating the UV light into visible light so that we can see it. And this is why you need sunscreen. Most of it gets blocked by our atmosphere, but a ton of it still makes it through. Exploring gas giants. So this is visible light. This is ultraviolet light again, and Hubble has an ultraviolet camera on it, and it can see these auroras, like the aurora borealis that we have here on Earth, on Jupiter. And they're crazy because there's all kinds of storms and clouds on Jupiter, and it's much bigger. So here goes Saturn through ultraviolet, and so ultraviolet, visible, and infrared. And this is, again, those auroras on Saturn this time, all brought to you by Hubble. X-rays, SOHO again, staring at the sun. This is the X-rays, also very dangerous, even more so than ultraviolet coming off. Luckily, most of those are blocked by our atmosphere. This is X-ray again, but brought to you by a different one. So this is the Starburst galaxy, and this is looking at the X-ray light, and Chandra telescope is pointing at that galaxy M82 to bring us that image. Then here we have the Fermi telescope. Fermi, the guy they named this after, was crazy. Super intelligent, but an interesting character. This is gamma rays, and this is pointed at our galaxy, pointing at the center of our galaxy. And you can see that it's a little more intense in gamma radiation in the middle and less so on the edges, and you can see some pulsars and a blazar, and we'll talk about what some of those are when we talk about the life cycle of the sun later on. So the last question. Your success criteria was, I will describe some characteristics of the forms of light so I can then use that knowledge to understand how scientists use light to study the universe. So answer the success criteria in the chart on the last page of your notes. So just fill in all of those squares on there. That will be your answer to your success criteria, plus the question at the bottom, which is to describe why scientists use different types of light, just right underneath the table there. When that's all said and done, based upon how well you can answer this, I want you to judge yourself. You don't have to share with me, but just judge yourself. How well do you think you accomplished your success criteria? Was it a 1? Not very much at all. Or was it a 5? You were great and you understand it and you worked hard at it. Both. Or maybe like a 3, maybe you worked really hard but you still have tons of questions, or 4 where you have a few questions left and you put in decent effort. Whatever you judge is good enough for me. Thanks, and see you next time.
Hopefully the video was helpful, and if you have any questions, just leave them below and I'll answer them, or bring them to class and we'll answer them then when we're working on stuff face to face.